truth values must be either true or false. And so this is the definition of truth values. And you should probably take note of that. And so there's something that we need to address before we start this part of the section. So when we're learning about our statements, we need to know the order for which the statements are addressed. And so this is just an idea of how I see it. And you'll see what I mean in a while when we're going to talking about truth tables, which is the next big thing we're going to do after we define stuff. So we have a compound sentence. And so what does a compound sentence give us? It gives us a compound statement. Compound sentences give us compound sentences. Compound sentences give us compound statements. If I said it wrong, I clarified it now. So there you go. And so what does a compound statement give us? If you guessed it, it gives us our components. Or you could say statements before we go to components. So just for the sake of not getting confused. And then from statements, what do we get? Which is our P's and Q's and R's, right? Which that just gives us our components. So we'll learn different words for these in a bit, but these are the most general words, and what I highly advise to know the process. And so we're given components, so I'm going to describe this, so just in case you're confused. Let's say we're given components P, Q, and R, right? We could make statements out of these, right? We could define them, our components. We could give them names, right? Statements and stuff, right? We'll be like, John can run. John is fast. I don't know. Something like that, right? And so we can make compound statements, right? We could say P and Q. What we've been learning, right? P and Q, P or Q, etc. Or we could say and so forth. And so let's see, John is fast, right? So let me just type it so maybe it's better to see. John is fast, and let's just say our Q is and John is thin. And so that's going to be our statement. Compound statement. I'm going to put it right here. There you go. And so now I want to define Q over there, just so you don't get confused. And so we got two statements. P, John is fast, and I put join instead of John. I just saw there, you know. And so I'm going to erase it. That gives you some time to think about this and why it makes sense. And then once I finish explaining it to you, I'm going to explain it one more time. So feel free, if you understand this, to fast forward. So John is fast and John is thin. And you probably could see that for the most part. There. And so what are these compound statements give us? They end up making compound sentences, right? And so we just put this over here, And that ends up giving us a sentence. Alright, these two conjoined statements. John is fast. And John is thin. And I hope this makes sense. And then I'll explain it to you going the way the arrows are pointing. So period, right? Because this is a sentence. So John is fast and John is thin. And so now I want to break it out to my compound statements. And so now I gotta define my sentence in terms of P's and Q's. And you can see that as following. So first, we're given a sentence, right? And then we want to make our sentence into a statement. And so we already have it as a compound statement, but now we want to define it as in P's and Q's. And so we do that. We say P and Q. And so now we look at our statements separately. And so now we're saying, oh, John is fast and John is thin. So now we understand what is defined. And then finally, we could just figure out what the components are, which we just did right here. So they go hand in hand, right? So if I want to make up a sentence, I use P, Q, and R. And then I come up here and then I make my statements. So John is thin, John is fast. And then I can put them together, compound statements. And then from there, I'm going to have a compound sentence, right? Because I could say John is thin and John is fast, right? Remember that rule that we're talking about? It's what do you call it? I'll tell you right now. So let's say we had 2 plus 2. Or let's say use a different number, so it's a little more, we can remember, right? We had 2 plus 3. And let's say we wanted to put 3 plus 2. So what do these both add up to? I'll give you a couple of seconds to think about it. Alright, you figure it out. They add up to 5, right? And so, if you remember what this is called our commutative laws, or commutative property, right? For algebra. So, it kind of went over my head, so sorry about that. So that's called our commutative property. I didn't want to keep you waiting, but this happens. So we got our commutative property, and right here we're going to have what we define it for logic, we call it our commutative law, right? There you go, my bad. And so I'll put a different color so we could clearly see it. Right, if we wanted to flip this, and we wanted to say P, or actually Q and P, right? Then we could do that. So we could do that. And so that just covers this before we get ourselves into this next section. So the definition of negation. Alright, what do you know about negation? If you remember, we had this little sign. There's a symbol called is not, and then we remember that is denoted as is not. And so that was a general definition of negation. Now we're going to learn the formal definition of negation. And it says, if P is a statement variable, the negation of P is not P, or it is not the case that P, and is denoted is not P, it has the opposite truth value from P. If P is true, is not P is false. If P is false, is not P is true. And so what does that all mean? Well, it basically described everything that we already went over, except for the last part, and we'll go over that right now. So if P is a statement variable, the negation of P is not P. So we defined that already. So right here, it is not P. And this is new to us, or it is not the case that P. And that's just another way to saying it. It's not as important. And so, and is denoted negation P. And so we know that. So what's the new thing that we need to learn? And so I'll put it in orange. It has opposite truth values from P. If P is true, then negation P is false. If P is false, then negation P is true. So this is all new to us. And so what does that mean for us? Let's make a truth table. So this is your first encounter to what a truth table is. So let's do that. So I'll put truth table. And so when you make a truth table, you don't have to put that. I'm just putting that just for the sake of showing you and explaining what it is. So we're going to have a truth table for the negation P. And so I'm going to put it in orange so you know that I'm talking about this part of our statement. So this is a part of our statement that I'm going to define. So let's see right here. This is our definition, this is our statement, this is our truth table. So let's see. P. We're given P, right? And we wanted to find the truth for negation P. So we're going to write out the two components, right? So I'm going to put on top components slash statements. Because that's what they are. In this case, we could put variables, components slash variables, because I don't want you to get confused later on. So we're going to put components and variables. Right, because that's what it says up here. It says statement variable. So it's just so it follows the formal definition. And you know we've been talking about components. Like these are the components. So place. So we're given P and negation P. So what do we have to do? If you done this before, you probably wouldn't know what to do. But let's say we haven't done this before, which we haven't. We're gonna have to draw these little lines. So see this little line right there, and we're gonna draw another line. And so these past videos we're talking about true and false. So what are the symbols we use? We're going to use T and the two symbols we use for truth tables. And so we gotta put it like this, which is going to be confusing at first, but when you get to the next examples, it's going to be explained better, because you're going to have more components and more to work with. So right now we don't have that much to work with. So we're going to put true and false. Alright, you got that? True and false. And so if this is not P, then it's going to be the opposite of what this says. So this says the opposite. So that obviously means that if P is true, then is not P is false. And so right here, if P is false, then is not P has to be true. And so that's how we make a truth table. So this is a really rudimentary truth table. And so let's define P. So we just, for the sake of understanding it a little bit more. So let's say P stands for James is tall. And so I'll just use the same kind of bland statements. Just so it's easier, right? We've been using the same statements. So James is tall. And let's say this is true. If it's true, then James is not tall, which is going to be negation P. James is not tall is going to be false. And so that's just the gist of it, right? If P is true, so let's say that's true, then this obviously has to be false, right? Because let's say James is 6 feet tall, then obviously James is not what do you call it, short. And so I was just using a subjective kind of idea, right? Because being tall is subjective. But for the sake of this argument, we're going to say James is tall. We're not getting into that kind of stuff. And let's say right here, the next one says James is tall, and that is false. Let's say James is 4 feet tall. So James is 4 feet tall. And so he is not tall. And James is not tall, which is true. And so that would be our truth table, right? Because it goes P is false right here. We should go and circle it. P is false. Right here, P is false. And then we have negation P, which is right here. Negation P. And James is not tall because he's only 4 feet tall. And so that's the basics of this, and we're going to move on to a harder problem.